Welcome to part 2 of our interview with Dr. Timothy Griffin of the Oklahoma Medical Research Foundation. Watch as we dig a little deeper into his work in osteoarthritis. What other types of joint loading have you found or do you predict would be successful in preventing damage?
Well, so one of the things that we're trying to understand, when we talk about joint loading, we're really working at kind of a very basic science level where we can do this in a couple ways in the lab. We can actually mechanically load cartilage tissue while the cells in the tissue are still alive in the lab environment. So we can cut out the cartilage, and we have a machine that can apply mechanical loads, and we can very precisely say how much stress we're going to apply, how long we're going to apply that stress, and are we going to do that in a cyclic fashion, so on, off, and how quickly we'll do that. And so we're looking at a very basic science level, the magnitude and the duration of the loads that can kind of be protective versus damaging. And then we translate that information into some of our animal model work, where we work with mice and rats, and we have running wheels. So we can put the animals on these running wheels, and we can look at when they voluntarily run, how does that affect the health of the joints? And so that's kind of how we're trying to understand loading in the context of obesity in particular. And so what we find is that when animals are allowed to run on these wheels, if we allow them access to these wheels, when we give them a high-fat diet, that can actually prevent the onset of osteoarthritis that we normally see when we feed animals a high-fat diet.
Wow.
At this early stage. So it can be protective, even when the animals aren't losing weight with the running. So they're still gaining weight with the high-fat diet, but there's something about running at that early stage that seems to be protective.
And is this the same research project that ANRF funded you for, or did you tweak it a little bit at all? Or?
So ANRF funded me for working on the work with the cartilage tissue itself, where we were loading in the lab. Okay. And so that gave us some really great insight and using new technology. So we work with a colleague who does proteomics, which is kind of a fancy word for being able to study very specific proteins within these tissues. And so from that work, we were able to use proteomics to look at how different types of loading affected the cartilage antioxidant levels. So we often think about antioxidants as things you have to take or eat, but our cells are full of antioxidants, and so the body has its own antioxidant defense system. And we wanted to know, we hypothesized that these protective loads, we think these kind of the loads that would be more equivalent to walking around or some light jogging around, that actually upregulated our body's own antioxidant system, in particular within the cartilage. And that's what we found. We found that some of these antioxidants would be increased with the more physiologic types of mechanical loads. And so we think that's one way in which mechanical loading, like for the walking and the light running, might be protective.
Do you hope to kind of test this in humans eventually?
Well, we'd like to get to that point at some point, and it'll be probably through a collaboration, since our lab isn't set up to bring humans into our lab. But that's what we'd like to eventually get to the point where we can see how can we apply this information into the patient population that will really benefit from this research. Yeah. And so there are a number of different ways that we might be able to do that through this basic science. We could identify certain types of molecules or some types of antioxidants that are very responsive to these good forms of mechanical loads. And so now if we know that this is how the cells normally respond to these good forms of loads, that might allow us to develop a drug that tries to activate that very specific type of response.
Where else would you like to see your research go, like in the next 5 years, say?
Well, one of the things that the field is really discovering is that there are likely different types of forms of osteoarthritis. One direction we'd like our research to go is to develop new techniques to help us identify these different pathways to osteoarthritis, so we can have more tailored treatments that are not kind of the general OA, but more specific types of OA. So that's one direction that we're heading in, and it's kind of falls in line with the general direction for the field. I guess I'd just say this is a really exciting time for the field of osteoarthritis. We've seen a lot of changes in the past 5 to 10 years, and I think we're gaining a lot of momentum. It's a disease that affects so many people, And it impacts their livelihood. It impacts their ability to live kind of independent lives as they age in particular. And so this is really, I think, kind of the tip of the iceberg. If we can get this, we're going to have even much more benefits to improve people's overall health and well-being. So thank you very much for the work that you do at ANRF in supporting our research, because I think it has very broad impact.
Well, yeah, thank you very much, Dr. Griffin. We appreciate your time. I know you're busy, so we'll let you get back to it, but we look forward to hearing more about your research soon.
Okay, well, thank you very much. I appreciate it.
All right, thank you. Thanks for watching part 2 of our interview with Dr. Griffin. At the Arthritis National Research Foundation, we believe that research is the key to finding a cure. Stay tuned next month as we talk about another research project that's making a difference in the arthritis community.